Okay, we are going to today cover chapter 7 of the text. This is the last chapter. So in construction 3360, when we're done with chapter 7, we are done with the course. So this is timber yet, but it's the connection devices used for timber. Okay, we basically have bolt screws and nails. We aren't going to deal with bolted joints or screwed joints, but we are going to deal with nails. Okay, so if you were putting a bolt in, of course you drill a hole, stick the bolt through, put a washer and a nut on the end, tighten it up and you've got it. If you've got a screw, you use some sort of a screwdriver or a mechanical driver of some sort, or you get a power driver. We typically use a battery operated impact driver. It just kind of spins it and bounces it a little bit and puts it in. So that takes care of those two, and that's about all I've got to say about them. So bolted joints is chapter 7.1. No test material associated with that at all. 7.2 and 7.3 there is. Okay, 7.2 is nail joints, and 7.3 is a gusset joint. So nails, we've got two pieces of material, or three, whatever we have that we want to put together. Okay, hopefully everybody knows what a nail is. That happens to be a 16D common nail. Okay, it's got a head on it, a shank. We use a hammer, of course, to put these in, or some pneumatic tool, or a gas-operated tool. So we can shoot these in, or we can beat them in. It doesn't matter. The ones that we shoot in typically have a little red coating on them. That coating, when we shoot it in, the nail heats up from friction and melts that coating, which is actually a glue, and it actually helps hold the nail in place. Gives you a pretty strong joint. So the nail, okay, a nail is, and this is what we're using. We're going to use a common, okay. So a nail is put into some wood, and if you look at the table is the whole chapter actually. So if you understand this table, you understand the chapter. The table is on page 262. It's table 7-1. The table is busted into two parts. And then if you start looking at those parts, hopefully you will see that there's 3 horizontal rows in the first part and 2 in the second. So the difference, part one is for gussets, plywood. So this has plywood. This table is going to be used mainly for 7.3. It's plywood gussets. Okay, in there they have these numbers. So if you look at it closely, you'll see 3/8, you'll see 15/32, and you'll see 23/32. Okay, these are the actual thicknesses of the plywood. We will not be calling those two this way on a test. 16/32 is a 1/2 inch. This will be known as a 1/2 inch plywood. 23/32, add a 32nd to it, is 24/32 is 3/4 of an inch. So the numbers you're going to read on a problem are going to be plywood, 3/8 inch thick, 1/2 inch thick, or 3/4 of an inch thick. So 1/2 inch, you'll use this number, 3/4, you'll use that number in the table. So that'll get us by column number 1. Column number 2 is how long the nail is, its length. We're not going to be using that column except for just reference numbers, okay? We may use it a little bit, but very little. It is significant, but not in this chapter a lot. The next is the diameter, how big around it is. We're not going to be using that at all. So if you want to kind of put a little X through that, that's fine. We are using the last two Okay? We don't buy nails by the length. Okay? We get them by the length, but we don't buy them by the length. If you went to Home Depot, Lowe's, and you said, I want some nails, they don't ask you how long you want them typically. They ask you what size. Okay? The size is called pennyweight. That's what that column says, nail pennyweight. I heard from an old timer that years ago what it was is if you stack pennies up vertically, the length of the nail was the number of pennyweight. So this is a 16 pennyweight nail. Okay? So if I stack 16 pennies up, it would be this tall. That's what I was told. I'm not sure if that's lore or if that's fact, but an old timer told me that one day. So the bigger the number, the bigger the nail. 16 penny is bigger than a 24 penny. 16 penny is bigger than a 12 penny. A 12 penny is bigger than an 8 penny. We use basically 3 types in the field normally. The 3 nails you'll see all the time are a 8 penny, 12 penny, and 16 penny. This is a 16. Okay, we use this typically to put plywood to dimensional, dimensional, and lumber to lumber, or lumber to dimensional. So this would be like plywood, these guys, tying that. Where would I use that? Like on a floor. I got floor joists. I'm putting decking on it. Nail it, that would be that guy. This, I've got a 2x, let's say even I got a lamb beam, and I'm going to tie a 2x4 to the side of it. That's what I would be using that for. Now if I've got maybe a piece of 2x, and I want to put a 1x on it, that's where I'd be using this guy. So a 1x is 3/4 of an inch, okay? A 2x is 1.5 inches. So those are pretty common. They have several more there. You can see they go 6, 8, 10, 6, 8, 10, 16, all the way up to a 50. 50 pennyweight's about that long, okay? We use those for putting retaining walls in with railroad ties or landscape timbers where you need a big long nail to tie them together. So pennyweight is the size. Now, don't ask me why, but if you went to Lowe's and you bought a box of nails, I sent you there and said, go get me a 5-pound box of 16 pennyweight nails, 16 nails. When you got there, this is what you would see written on the box. D. Okay? So on the box, this would be 8D, 12D, 16D nails. And that's what they've got written there. 6D, 8D, 10D. That's right on the box at Lowe's, Home Depot, wherever you go. So once you got the pennyweight, you're all set. And then the last one is how much one nail will carry. So if you look at the last one, it's the load per nail, how much one nail can carry. Okay, how is this thing developed? Okay, if you look at the things that it says influence, I'm back on page 260 right now. Things that influence how much a nail can carry. Number 1, the nail size. So 1, nail size. On your table, this is addressed in the pennyweight column. So we know how big it is. The bigger it is, the more it should carry. Makes sense. Next one, load direction. Okay, we're not going to deal with much there. Load direction. What do I have to worry about? What are the directions it can carry? Okay, if you look at a member, I got floor joists. I got decking on top. I put the nail in right there. Do I really need that nail other than the ability of that decking to shift. It's in compression. It's not holding load. It's just holding the member in place. That happens for decking. It happens when we build a wall. There's the plate on the bottom. I nail it through there. I nail it through the top. It's not holding any load. All it's doing is keeping the stud in the right position. Okay, so compression's one. That's no big deal. Okay, tension. Okay, I've got to let me do something here. See something that makes sense to you. I've got a member nailed to another member, and it's pulling down. Now that's trying to yank this joint apart, and the nail is trying to prevent a tensile movement, a movement that's in tension. I'm pulling on it. Tension means pull. Tension is not allowed by code. Okay, it is allowed for if you're playing with temporary structures, like when we, in the next course, when we do form work. If it's just going to be there for a little bit, holding a temporary load, they will allow us to put a nail in tension. But if it's permanent, there's no tension. How do we get around it? I don't know if you guys have heard of these, but they make a device called Simpson. The company Simpson makes thousands of devices and items that you can use for putting wood together that eliminate the tensile force by a positive connection. Okay, what I'm talking about, hurricane straps down south. We build a roof, we put the rafters on, it sits on, the roof is basically sitting on top of the walls with a couple little nails holding it together and gravity. In Florida, we can't do that. We put a strap in there that goes to the rafter and ties positively to the wall. We've got straps that hold the wall to the foundation, to the floor. We've got joist hangers. Got a joist hanger. Got a joist coming into the side of something. We will take and we'll put joist hangers on it. So we've got a lot of devices. Simpson makes a lot of them that will tie and take care of that. For this course, all we're going to worry about is shear. Okay? So the nails we have are in shear. So if I look at a big glue lamb in your barn, you're going to hang a loft from it or something. That's pulling this way. These are in shear. So our load direction for us is going to be shear. And that's what the table addresses. Loads in shear. Okay, number 3. I'm going to save for a minute. Species and grade is number 4. For us, this table is specific. If you look at it and you read the top of the table, actually read the bottom of the table. Adapted, let's see. Nails anchored in sawn lumber of Doug fir larch with a G of 0.50. So we're putting it in a lighter wood. Hopefully, I don't know if many of you have ever had the opportunity to do remodeling. If you do remodeling and you find a wall that's made out of oak studs, old oak studs, it'd be remodeling old building type houses, buildings. If you grab a hold of one of those nails that's in an oak stud, you better bring your lunch. You'll be there a long, long time. I can pull a nail out of balsa wood a lot easier than I can out of pine. So the density of the wood makes it harder to put the nail in it also makes it harder to pull the nail out. We only have one. We got Doug fir larch, so the table takes care of that. So Doug fir larch is in the table. So the only thing I got left that's on that table, so I've covered what on the table? I've got the penny weight. I got the length and diameter are a function of the penny weight. I got the side member and the load left. Okay, why do I need the side member? If you look at number 3, it says penetration. Okay, penetration. I'm going to use real numbers here. Let's say I've got me a glue lamp. It's a piece of engineered wood. Say it's 3.5 inches thick and it's 11.25 inches tall. I'm going to put a 2x4 into it. So I'm going to take a nail. And I'm going to, let's say it's a 16D. I look at my table, and a 16D, according to this table, says it's 3.5 inches long, which it is. So this nail is 3.5 inches long. How much does it penetrate into the glue lamp? What is this distance right here, the penetration? Right there is the penetration. If I know the size of the nail, 3.5 inches, and I know the thickness of the side member, do I know the penetration? Length of the nail, 3.5 inches. Side member, can I take the 3.5 and subtract the 1.5 from it and find out how far it went into the other piece of wood? That's how the penetration is addressed in this table. A combination of the length of the nail and the side member. The side member eats up some space. If it's a 2x, it does 1.5 inches. If it was a 1x, it would be 3/4 of an inch. So that's how we get penetration. So that satisfies the criteria in the book, and that's basically the real criteria in the real world of how penetration is figured. So let's take a look at this. There's only one other thing I need. I addressed part 1. That is plywoods or wood. Okay. Part 2 is lumber, and I've talked about it. 2x, 1x,